Oke guys, so sekarang jam setengah satu. Aku kalau misalnya tidur sekarang, pasti aku nggak bakal bangun sahur. Jadi kita bakal belajar sampai sahur. Mungkin aku bakal sahur jam 2, habis itu tidur. Oke, so tapi dia aku pasti ketiduran sih. Mataku sebenarnya udah ngantuk. Tapi kalau misalnya aku tidur, bahaya. Jangan lupa. Ah, harus pakai kacamata nih. Aku takutnya mata aku udah terlalu berat kalau pakai kacamata makin berat. So, ya, jadi sebenarnya aku nggak menyelesaikan target aku hari ini dan itu sangat wow. Atau tadi tadi aku tiba-tiba ada kegiatan udah banyak pengen a lot of yep just belajar bro, belajar tinggal belajar. Alright, so biasa aku masih jam hari ini masih praktikum pemrograman aku jam 8. I think it's alright, but ya seharusnya target aku hari ini tuh adalah menyelesaikan 2 bab, dan aku baru menyelesaikan satu babnya lagi belum. Bab satu lagi itu is about the first one is this one. Dan udah selesai sama apa ya, dan bagian lainnya itu adalah deep learning. Aku jatuhnya sebenarnya udah sih, udah semua 9, 9, 9, 3, 3, 7, 7, 5, 5, 2, 2, 2, 8, 6, 7, 10. Ini apa yang belum? Asing, introduksi. Ini kuis-kuis ini kan nggak perlu. Ini kuis-kuis ini nggak usah sih. Deep learning, 4489 apa nih? Size, guessing it's done. Appendix ini nggak usah. Nah, kita tuh masuk ke software integrations. Oh enggak. Sebelumnya itu aku mau masuk ke, kayak itu besok aja deh. Itu sekarang. Sekarang aja deh. Gak apa-apa. Jadi aku tuh hari ini seharusnya ya buat penyelesaian juga yang bagian software integrations. But ya, aku tadi ada menyibukkan diri. Sebenarnya bisa aku belajar, tapi aku malah melakukan hal aneh lain. Maafkan diri aku sendiri, maafkan. Harus aku kasih hukuman. But it's okay. Tapi di sini, nah di math ini sebenarnya aku udah pernah belajar sih. Matrix, matrix vector, scalars di SMA, di kuliah juga udah belajar. Nah ini tensor, ini lumayan beda, menarik.
In the last parts of our program, we make use of the
Headset gue mana, Cuk?
state-of-the-art deep
Can we skip to the good part? Can Can you realize my work here? Can you realize my work here? Makan apa ya? Kayak aku beli di luar aja.
learning framework developed by Google called TensorFlow. TensorFlow works in a peculiar way, but one of its in the last parts of our program, we make use of the state-of-the-art deep learning framework developed by Google called TensorFlow. TensorFlow works in a
TensorFlow dari Google. Anjir, lumayan banyak kan pakai produk. Ada Gemini, ada Flutter, ada Firebase, ada TensorFlow.
peculiar way, but one of its main characteristics is that it works with tensors. So, it is only right that we introduce tensors now. The mathematical concept of a tensor could be broadly explained in this way. A scalar has the lowest dimensionality and is always 1 by 1. It can be thought of as a vector of length 1 or a 1 by 1 matrix. It is followed by a vector, where each element of that vector is a scalar. The dimensions of a vector are nothing but m by 1 or 1 by m matrices. Okay. Then we have matrices, which are nothing more than a collection of vectors. The dimensions of a matrix are m by n. In other words, a matrix is a collection of n vectors of dimensions m by 1, or m vectors of dimensions n by 1. 1. A scalar. The dimensions of a vector are nothing but m by 1 or 1 by m matrices. Okay, the dimension of n vectors of by 1. Collection of scalars, too. We know all that already. Let's get to tensors. Now, a tensor is the most general concept. Scalars, vectors, and matrices are all tensors of ranks 0, 1, and 2, respectively. Tensors are simply a generalization of the concepts we
Tensor 1 by 1 and 1 times 1 and times 1 and times n.
have seen so far.
These are simply generalizations of the concept we have seen so far.
An object we haven't seen is a tensor of rank 3. Its dimensions are k by m by n. It can be thought of as a collection of matrices.
It's collections of matrices.
In terms of programming, a tensor is no different than an ND array. And in fact, tensors can be stored in ND arrays, and that's how we often deal with the issue. Let's create a tensor out of two matrices. Our first matrix, M1, will be from the first example. The matrix M2 will be a
Berarti sebenarnya dia mirip sama ND array.
different one with the elements 9, 8, 7, and 1, 3, minus 5. Now, let's create an array, T, with two elements, M1 and M2. After printing T, we realize that it contains both matrices. It is a 2 by 2 by 3 object.
It's 2 by 2 by 3. And where the fuck is 3? Where is it coming from? Kenapa bisa ada angka 3?
Contains two matrices, 2 by 3 each.
Oh, gitu cara bacanya, masuk akal. So, ada dua matriks yang berisi 2 kali 3. Oh, gitu.
All right. If we want to manually create the tensor, we would need to write this line of code. As you can imagine, tensors with lots of elements are very hard to manually create. Not only because there are many elements, but also because of those confusing brackets. Usually, we would load, transform, and pre-process the data to get tensors. However, it is always good to have the theoretical background. This will do for now. Thanks for watching.
Okay, so kalau bisa aku catat ya. Apa aku catat di belakang? Sebenarnya di bagian ini sih. Di bagian di belakang ini sih. What basically is tensor? Nah, kita cari di sini. Tensor. Oke, ini aku udahin aja deh. Misalnya aku udah pernah belajar di kampus atau di SMA, nggak perlu ngulang lagi sih. Oke, jadi ini sebenarnya bagian math sudah done. Python pun udah aku belajar. Harusnya aman sih. Dan untuk bagian aku testing practical example-nya aku tuh. Dan ini masih centang dulu belakangnya. Python-nya nggak usah, karena aku udah belajar ya mas sendiri. Python-nya nggak usah, aku udah ada Jupyter. Hmm,
This lesson, we'll do a quick tour of the Jupyter dashboard. As soon as you load the notebook, the Jupyter dashboard opens. Each file and directory has a checkbox next to it. By clicking and unticking an item, you can manipulate the respective object. That means you can duplicate or shut down a running file. In addition, you can rename and delete folders. The selection menu allows you to select all the files in the console of the same type, like our case, running, you like, play shut directly. Other folder, you can upload, and when you select it, appear, and you can expand most file action. Click on new name, the iPad. Let's carry it. Done. Expanding a new tab for me, code, and see its output. More on that in our next lecture. Thank you for watching. Okay, great. Now that we know more about the dashboard, we are ready to examine the see here is called you'll be able to this is called input field. On the top right corner, indicate that as well. To close edit mode, you have to press the escape button. As I press escape, I'll go back to command mode, which will disappear. X is a list. Hold code or selected an input field. On the second option, hold shift in a new cell. You can continue typing code easily. You can use the buttons on the main menu. Since we are keen supporters of ergonomics, we suggest you get used to the keyboard shortcuts. When coding, cuts in the X key. Remember, you can always use the arrow keys to navigate along your notebook file. Paste it. Press the V key. The arrow keys again to go buttons in the menu. Selected cell up or down moves along complex code that require will appear. This class. Three other shortcuts cell. After I select the same cell and press B, another cell will be created. Stated. Work will contain some message. Markdown cell. You should either expand this list and opt for markdown, or simply press the M button. Press enter to access the cell and type some text. When I run the cell, the output will be a simple statement. Now, if you want to turn a markdown cell back to a code cell, select it and opt for code from this drop-down menu. Or press the Y key. To conclude, there are two advantages of using Jupyter. First, when your code becomes long, explain the solution you've created. Using this app is you can select and run a particular cell, patient time. You need to know Python. Thank you.
Nyaman lah.
When programming, not only in Python, if you say that a variable has a numeric value, you are being ambiguous. The reason is that numbers can be integers or floating points, also called floats, for instance. Integers are positive or negative whole numbers without a decimal point. Let's create x1 and bind it to the value of 5.
The fuck is this? Apa itu barusan? Baru tahu aku ada terminal juga sih Udemy ini. Anjir banyak Python nih cek. Kebanyakan di Python nya anjir.
Alright.
Kenapa aku dulu belajar Python gak dari sini? Aku dulu sebenarnya pas belajar Python itu lebih learning by doing sih. Pas di kampus karena bidangnya gampang banget kan. Jadi kayak udah ikutin aja. Defining function, tentang function udah aman. Apa kira-kira menarik? Hmm,
It isn't a secret.
aman
We can have a
semua.
function within the function. For instance, let's define a function called wage that calculates your daily wage. Say you use working hours as a parameter, and you are paid $25 per hour. So this should work. Okay, good. Notice, I don't
Aman.
technically need the print command here. I could print out the wage afterwards, but I don't really need to. So I'll
Oh,
proceed
kayak
this way,
list
just
gitu.
returning the value I need. When you do well in a day,
List slicing. BAC-nya. Data pools. Dictionaries. Ada iterasi. Kebanyakan di Python-nya ya.
the same output we obtain.
Ini capek nyentang aja. Nah, kalau misalnya Python itu centang,
I thought
20% gitu. %78% aja. Dengan mencentang Python jadi 78%. Emang berpengaruh banyak anjir Python-nya. Nah, berarti sekarang aku masuk ke ini udah semua. Software integration ke sini. Sebenarnya juga aku udah belajar nih set client API di web. Tapi semoga aja ada hal baru yang bisa
today's business world, terms like API, software, data, and servers are used. Today's business world, terms like API, software, data, and servers are used so often that you might think everybody knows their definitions by heart. However, do they? And do they need to? If you are a software developer or a data scientist, then yes, you most definitely do. Otherwise, having just a vague idea about the entire picture will be sufficient for you to work as a business or financial analyst, for instance. Let's go through a few definitions that will make things clearer. Data means information stored in the form of symbols, ones and zeros, other digits, letters, special characters, etc. Thus, it can be collected, measured, analyzed, and processed further. Where can you find data? Well, we are not talking about physical books with thousands of written pages, or the enormous accounting ledgers from the 60s. Data today is stored practically in databases. The latter represent an electronic collection of data, or a structure filled with information, if you prefer, organized in a way that is easy to access, manage, and update. And where are databases stored? In database servers. As a matter of fact, server may be a misleading term for a newcomer, since its definition can have a specific application in different scenarios. Theoretically, a server is a combination of hardware and software responsible for storing, managing, and processing large amounts of data. The most common types are the web servers, database servers, and FTP servers, free transfer protocol. These facilitate the transfer of web pages. Most common types are the web servers, database servers, and FTP servers, free transfer protocol. These facilitate the transfer of web pages, database queries, and files respectively. All are different servers. Otherwise, an example of a scenario would be the client-server model, where servers exist to respond to the requests made by a client, This model works in the following way. A client requests a service from a server, for instance, to have access to some data. In this example, the server is a piece of software that will provide this service, or this specific amount of data, to the client. Say you are about to request or pull information from a web server through a browser, the latter being the client in this example. You can transmit your request to the server and, in return, obtain a response, also called a reply. Moreover, when we are talking about web servers and browsers, you will obviously need an internet connection. Alternatively, local servers exist as well. Imagine the headquarters of a large company, employing thousands of people. Of course, a lot of information is stored on its servers, and to access the information you need, you would have to use a cabled connection. However, the data won't be stored on an average desktop computer, as its capacity won't be sufficient to handle the processing of the vast amount of information requested by the employees. That's why specialized big machines that have much more powerful hardware designed for storing huge amounts of data are being called servers too. Another instance is the mail server, which has been created to act as an electronic post office. It is a mixture of hardware and a software application again. The latter follows universally accepted standards for storing and exchanging email messages and other data files such as text, image, or multimedia. It is thanks to mail servers today that we can send and receive letters over the internet with people from all over the world. Nevertheless, don't let the definitions of the word server confuse you. In a way, a server is always a combination of hardware and software, and it is related to storing, managing, and processing data. All right, great. We hope notions like data, servers, clients, requests, and responses sound a lot more familiar to you now. Nevertheless, the picture you see here is not quite complete yet. It overlooks fundamental elements that are a must for developers, software engineers, and data scientists. What are they? You'll see in our next video. Thanks for watching. Having clarified what data, servers, clients, requests, and responses mean, we can move on to explore other terms that will shed even more light on data connectivity. Developing and maintaining data connectivity is one of the most important things of all. It regards the ability to connect clients and servers, securing the swift and voluminous transfer of information between them. This is not a new subject. Today, unprecedented amounts of data are being sent from servers to clients and vice versa. And if it wasn't for data connectivity, this wouldn't have been possible. Okay, but how does it happen? How can one connect information from multiple servers simultaneously? How is this data delivered to the clients? The simple answer is by using APIs. Application Programming Interfaces, APIs, are the software tool that makes this entire beautiful picture a reality. Technically, an API is a contract allowing software to share data with each other. Otherwise, in simple words, it lets devices and software applications communicate in real time. Nonetheless, we imagine this term is not really clear to everybody. Let's describe its meaning word by word. First, remember an API is a type of an interface. But what is an interface? Think of a device, for instance a cooker or a TV set. Obviously, using inputs, a device is capable of executing certain operations to produce outputs. The cooker uses electricity, which is an input, to heat up its oven, the output, while the TV set uses electricity, an input, for displaying a film, the output. This means devices are capable of executing specific functions. But how do the cooker and the TV set relate to the outer world? Through interfaces, or even more specifically, through the endpoints of their interfaces. In our kitchen example, the cooker's plug can be considered an endpoint of the cooker's interface, while the electricity socket an endpoint of the power supply. By connecting these two, electricity can flow from the power supply to the cooker, which can then provide its function to heat up the oven. Hence, the connectivity between the power supply and the cooker is realized by connecting their respective endpoints. The case of the TV set is even more interesting. Look at the back panel of such a device. So many inputs form this interface, and they are all endpoints, as various devices can be attached here, the left and the right channel of an audio system, a VGA screen, and more. In addition, the TV cable's plug is another endpoint, as it goes to the power supply socket. The situation in the digital world is analogical. As we already said, to execute their inherent functions, software apps, in their capacity of clients, need access to specific types of data contained in some servers. Let's add more elements to this composition though. Who are those using apps? People or other software? They are their end users. Who is creating them? Business developers and software engineers. Namely, the latter are the end users of the APIs, which allow them to connect to the data servers. This means APIs are a collection of endpoints to which developers can attach and then extract specific information that can be used by those who are working with the apps. Furthermore, do not think that people connect to such data servers just to retrieve bulky datasets with text, numeric values, audio, or video files. Apart from access to such information, servers contain and provide specific software products too. The term comprising the types of information you could obtain from a server is data assets. A data asset in general is just data that is expected to have some value in the future. Everyday examples include intellectual property, such as patents or a song you composed. You may obtain financial benefits from selling these assets later. As a consequence, a database with thousands of records is another type of a data asset, one you could later use for analysis and deduct valuable insights which will improve your business in the future. Other instances are websites providing specific text information or pieces of code. Therefore, data assets are any forms of data or software related to the processing of information. Having clarified the general picture better, let's go back to the other two words composing the term API. Application. Here, an application, often called just app, refers to a program designed to perform a specific set of operations for the end user, be it a person or another application. Instances of apps are web browsers, video editing programs, database management software, and so on. In the same way, all an oven does is heat up a meal. Applications have a specific purpose and are able to carry out specific tasks they have been designed for. Programming. Programming simply refers to the function the app performs. In other words, it regards the process of converting inputs into outputs. Therefore, from a programming perspective, combining these two terms with everything we just said about interface means an API is namely the technology necessary to process requests from the clients to the servers and, in response, brings the requested data from the server. So, an API acts pretty much like a messenger. To sum up what we've said so far, we can say a server supplies data and acts as the power supply from the kitchen example, while a software application acts as the cooker. It needs data to execute its operation properly. We believe you already have a good idea about why data connectivity exists today. In the next video, we will focus on this phenomenon from the technical side. How can so many programs written in different programming languages communicate between each other and transfer information at such a quick rate? Also, we will discuss in particular how APIs contribute to data connectivity. See you there! Recap. We first presented the client-server model to you. We explained that a server can receive a request from a client and return a response in the form of a file or a service. Then, in the next video, we introduced our other actors of the data connectivity world. More precisely, we said that data assets are being stored on servers, and each one of them has a specific type of digital interface, an API. Then, software engineers and developers access the data servers through these APIs in order to build software applications, which act as the end users of the API. Finally, they are intended to provide their end users, people or other apps, with information that will satisfy their requests. Looking at it from developers' perspective, the goal is to create apps that respond to people's needs better than those developed by competitors. A better app in general is one that works faster and more efficiently. To achieve this, it needs information from multiple servers so that its end users can get rich and to-the-point data as swiftly as possible. That's why, when creating the app, the software developer's job includes leveraging multiple APIs simultaneously, thus employing other technologies in its core functionality. Let's see a real-life example of the landscape. Think of Facebook, Instagram, Twitter, Google, Reddit. The list of similarly structured companies is countless. They all have servers, related web pages, and mobile apps. Now, imagine you wanted to read some posts on Reddit. You can do this via their website or mobile app. However, should you decide to use the text from the Reddit's post in your own app, you wouldn't be able to get them via the website or the mobile app. From a browser, you could only retrieve the posts in the form of text and code that is used to create user interface. To extract just the text without the code, you'd need to connect to the Reddit's database, where this text information has been stored, and pull exactly the data you need. You can do this through Reddit's API. Remember, the application programming interface is not the web page or the app. It is a separate technology, acting like a gateway to the server which you, as a programmer, can connect directly to. So, if you need information about the posts on Reddit, you'll have to connect to its database API and extract the relevant information from there, not from the web page or the app. Okay, but this database contains news, comments, ratings, reviews, and so many other things. Is it necessary that a single API deals with all of them? In terms of work overload, wouldn't this be too heavy for the API? Well, remember, an API is a collection of endpoints, and they practically split its functionality into parts. One endpoint is about Reddit's comments, another one about ratings, a third one for news, and so on. Therefore, a programmer will match his code with the desired endpoint only. And from a technical perspective, the most amazing thing about APIs is that sometimes everything you need can be accessed with the ease of writing just 2 lines of code. In fact, this might sound like a fairy tale, because it actually is. Almost. There are limitations to this story. To process your requests, an API does require maintenance, and this naturally costs a certain amount of resources. Furthermore, security is a big problem for these interfaces. So, the APIs must act as a filter that will prevent the system from malicious programmers and overloading, while at the same time guaranteeing quality access to its users. Finally, let's not forget that you will most probably have private information on your server too. Would you like the whole world to be able to access it for free? Of course not. That's why some services come at a certain monetary price, and as a consequence, using the API may sometimes cost and even be quite expensive. Nevertheless, the structure is out there, and data connectivity exists. It is possible to use the multi-million-dollar servers of some companies and add their servers to your app, thus improving its performance immensely. Sometimes, this will even let you come up with completely new functionalities. Otherwise, the entire process can be thought of from the reverse side too. If you are maintaining an app and providing specific services to other apps or people, in certain cases, you should build your own API on your server to improve the communication with them. That's another way in which good knowledge of APIs helps you share information with the rest of the world. Having your own interface helps you improve the functionality of the service you are offering. In addition, you can charge customers a fee, so technically, this could help cover some costs. Now, to clarify these abstract explanations, let's check another real-world example. Pick an online travel agency. Momondo, Expedia, Kayak, Booking.com, you name it. Each of these agencies is an online travel service that offers information from numerous hotels, airline companies, car rentals, etc. So, on the website, you could just indicate the dates of your flights, how many people are taking the trip, the number of rooms you want to book, whether you would like to rent a car or get insurance, and so on. So, these agencies are doing an amazing job. Using several APIs, they are delivering the information you need within seconds. All they need is your request, and then they will take care of the response that will be brought back to you. Amazing! Next, let's elaborate on why we prefer using them over a static database. First, as perceived from the online travel agency example, data is changing extremely quickly. An airline could cancel a flight, and you'd like to see this change visualized as soon as possible, right? Second, all you need is a specific bit from the entire dataset. You have no use of information about all cars available for rent during your stay abroad. The API's endpoints help you choose just from the cars that satisfy your criteria: size, daily price, and car brand, for example. Third, don't forget how huge the database of an external source could be. And if you think you could store the data of a car rental firm, just imagine how big the Google's database is. Hundreds of exabytes. It's insane. Storing this amount of information at home is impossible. However, accessing their data through their API allows you to obtain that relatively tiny little piece of information you want. We hope this video helped you realize how aggregating information from multiple servers by using APIs does not offer just a couple of advantages. This activity saves enormous amounts of your time, provides access to numerous databases, and is very efficient when delivering precisely the information you need. That's why using APIs is at the core of data connectivity. Our next step will be to project the same story from one layer deeper, explaining what software integration is in general and how it works. And a little more. Servers, web servers, databases, APIs, applications, all of these can be regarded as pieces of software with different functionalities. And it is thanks to the advancement of data connectivity today that enormous amounts of information can be shared between them. Now, let's explore another layer. Software can be written in any of the hundreds of programming languages out there. So, is data connectivity available just for Python or Java? Or is it somehow possible to send data from a program written in one language to a program written in another? It's no secret. In reality, it's the latter. For instance, it is one thing to type www.facebook.com into your browser, which is just a software application for surfing the web. In that case, your computer will send your request through the internet to the Facebook server and will bring back Facebook's web page as a response. Instead, when working with APIs, you don't use your web browser to ask a web server for a web page. You use a software application to request specific data from a server, and this data will be returned in a text format. On a technical level, different pieces of software, better referred to as software products, communicate through text files. Yes, you might be sending tabular data or specific text, but it is all, or at least it can be, converted into text by computers. More broadly speaking, it is turned into ones and zeros. The most universally accepted text file formats are XML, CSV, and JSON. In our theoretical example, the three cover the same functionalities, so for simplicity, we shall focus solely on JSON, which stands for JavaScript Object Notation. It is just an ordinary text file, so if you imagine a list containing the numbers 1, 2, 5, and 10 written in Python, the same list written in JSON will be stored as a string. If you want to pull a data table from an SQL database stored on an external server, and you want to extract it using Python, you'll need to write specific lines of Python code that will let you access data from the remote server through the server's API. The API will send your request to the server, and you'll receive a reply in a string format, for instance, JSON. Moreover, don't think your code or the data in the database has been converted into JSON entirely. Only the piece you've requested, the message produced by the remote server, that has been turned into the common text format. In addition, yes, all modern programming languages can read, export to, or work with JSON. So, instead of Python, had you used a programming language such as R or MATLAB, the server could have provided the data you need without a problem. Finally, with respect to alternative text file formats, developers find it a lot easier to translate or to parse a JSON string into the programming language they are using. Therefore, it is these common text files that allow incredibly different software products to communicate with each other. So, that's actually how APIs maintain and develop the beautiful data connectivity picture we enjoy in our world today, through text. On a different note, we just illustrated how APIs act like a messenger between the end user of the apps built by software engineers and the servers. They are like a gateway to the server, or a bridge between the two pieces of software. In fact, that's what interfaces do in general. They help you establish connections. There's one other term that stems from the communication ability of programming languages, and it is integration. You'll hear more about it in our next video. See you there. Integration is a rather vague term in programming. Basically, it wouldn't be wrong to say it has two main distinguishable meanings. The first one regards having a system, or an architecture, composed of a few different software products, various programming languages, or other pieces of software which can communicate with each other via APIs, or a common API. The second meaning of the term integration is the more classical one, which refers to a situation where multiple software products can be set up to work as one tool. The idea here is to enhance the functionality and the performance of an already existing application, thus solving a certain business problem quicker and more efficiently. Apart from the two distinct meanings, we could say there's a third type of integration. It represents a mixture of the first two. This is precisely the case of the example below. We will explore how a software program can be integrated with one programming language using the first type of integration, and with another one using the second type. Okay, now let's see an instance of software integration. Imagine a piece of software that could store the data you have on a local level, another product that could use it to make calculations, and a third one which could plot results beautifully, thus delivering the outcome of your research in a clear and easy to illustrate manner. Such is the case with SQL, Python, and Tableau. You can use SQL to organize, keep, and manipulate your data in a structure that can be sent over to Python for study. There, you can apply various statistical analysis tools to make predictions based on your current information. Then, Tableau, one of the most widely used tools for data visualization, can use the obtained output to deliver meaningful representations, allowing managers or executives to immediately spot the trends you have discovered or predicted. This form of integration is somehow centralized and happens from the point of view of Tableau. So, what can we say about integrating SQL and Tableau? We've reached the moment when we must explain the meaning of the term driver. A car driver obviously drives a car, and in a similar way, a software driver can drive a certain software product within another one. It is a piece of software too. However, its function is to mediate between two products. How is that possible? Isn't JSON a universally accepted format? How come Python and SQL will share the same type of code, not just an ordinary text file? Tableau has built-in drivers that can read code which is native to other programming languages, in this case, SQL. So, through Tableau, you can execute SQL code, and the drivers will help you apply the code you've written to the SQL database you've been connected to, thus delivering you the desired data. Then, using this dataset and regarding the combination of Tableau and Python, instead of passing information through the respective APIs, it appears that the two software products communicate with each other by sharing the same code and functions through a common API. My point here is, Python is one programming language. Tableau is a software written in another one, C++. However, the two software products can interact thanks to TabPy, which is a type of API called a REST API. From the perspective of Tableau, TabPy's server allows you to execute Python code remotely and on the fly thanks to a built-in driver. Then, you can use the obtained results in Tableau. So, different to using interfaces, where information is being sent from point A to point B over an API in a certain text format, this type of integration involves multiple software products having a common API and built-in drivers. Each component of the SQL Python Tableau system can send information that is afterwards processed towards the other components that have drivers executing the foreign language code. In addition, integration can happen online or locally, but in our example, you needn't think too much about that. Just remember that Tableau has built-in drivers that may leave the user completely unaware of their existence. Nevertheless, they allow Tableau to centralize the advantages of using SQL relations and Python computations to take the data from your database, apply state-of-the-art analysis, and then visualize the output in Tableau. Great! In the next section, we will work with Python, SQL, and Tableau to solve an ambitious business task. Are you excited to begin this challenge? I hope you are. Thank you for watching.
Tableau. C++.
Welcome to the first of a small set of lectures devoted to introducing you to our business exercise. Put yourself in the shoes of a business analyst and imagine you want to be in complete control of your analyses. This means that you must be able to manage the information you have stored in your database. You wish to have a substantial amount of mathematical and statistical tools to make better predictions with the available data. Furthermore, you would like to be able to create data visualizations that will allow you to present results in the most intuitive way. And here's the trick. Perhaps there is a software that has the functionality to cover all three areas. However, the database management ability of this program would not be at a level as high as that of SQL, nor will the range of its mathematical and statistical tools high as that of SQL, nor will this program would not be at a level as high as that of SQL, nor will the range of its mathematical and statistical tools be as wide and up-to-date as the ones offered by programming languages such as Python. It's even more unlikely that it will have the capability to quickly create sharp visualizations like Tableau does. With that in mind, which tool would you choose to get the optimal output from your analysis? Obviously, you would like to take advantage of all three, SQL, Python, and Tableau. To prove this is a viable option, we will go over a business case thoroughly, using three programs to find a proper solution to the initial task. Actually, there's always going to be another crucial ingredient for your analysis, and that is your capability to tackle the problem from a business perspective. Without the relevant logic and understanding, even if you are given the most effective dataset and software tools, you will still end up far from a solid and meaningful solution. Therefore, your knowledge of SQL, Python, or Tableau should allow you to be independent when conducting analyses. However, you'll finalize nothing unless you can stick to a plan to solve the problem. In other words, SQL, Python, and Tableau are just the means to help you follow your strategy and reach your end goal. In the next few lectures, we will focus on the business problem we want to solve and carefully look into the dataset at hand. Then, we will explain how to import and reorganize it in Python so that a statistical method called logistic regression will lead to an output which will allow us to better predict future outcomes for new observations. Finally, the fresh obtained information will be brought to Tableau, where you will be shown how 2 or 3 clicks and drags can swiftly deliver a data viz that will provide you with a deeper understanding of your results, therefore improving the accuracy of your expectations regarding the new observations. So, during this exercise, we will be shifting gears often. That is, we will be working on a few layers at the same time. We will go full throttle on the business logic, intuition, and interpretation, and we will delve into the programming languages and tools we have, SQL, Python, and Tableau. Of course, we will use software that is open source and completely free. MySQL Workbench will be our SQL environment. The Jupyter Notebook app will let us handle Python code, and Tableau Public will take care of all the visualizations. We will keep the task light in terms of software integration and will not spend time installing the additional server, modules, and drivers you need to combine the three tools. We will, however, preserve the same logic of exchanging information between them and achieve that by using CSV files. Are you with me so far? Good. Now, fasten up your seatbelts. The ride is about to begin. All right, so let's define the problem and see why it is worth our attention from a business perspective. The exercise will address absenteeism at a company during work time. The problem is that the business environment of today is more competitive than it used to be. This leads to increased pressure in the workplace. Therefore, it is reasonable to expect that unachievable business goals and an elevated risk of unemployment can raise people's stress levels. Often, the continuous presence of such factors becomes detrimental to a person's health. Sometimes, this may result in minor illness, which of course is not desired. However, it may happen that the employee develops a long-term condition, an example being depression. That being said, since we will be solving the problem from the point of view of the person in charge of productivity in the company, we won't focus on that facet of the problem. Rather, we'll look at predicting absenteeism from work. More precisely, we would like to know whether or not an employee can be expected to be missing for a specific number of hours in a given workday. Having such information in advance can improve our decision making. How? By reorganizing the work process in a way that will allow us to avoid a lack of productivity and increase the quality of work generated in our firm. So, here's how we'll define absenteeism. The absence from work during normal working hours, resulting in temporary incapacity to execute regular working activity. Okay, logically, here come some additional questions. Based on what information should we predict whether an employee is expected to be absent or not? How would we measure absenteeism?
Absence from work during normal working hours, resulting in temporary incapacity to execute the rules. Sejelek itu kah bahasa Inggris aku? Jer, aku panas. Sini. Kehadiran dari pekerja samping kerja normal resulting in temporary menghasilkan sementara incapacity menyebabkan ketidakmampuan execute absenteeism.
Should we rather think about trying to predict excessive absenteeism? We will answer these and other questions as we proceed with our analysis. For the moment, just remember that, as a whole, the purpose of the business exercise will be to explore whether a person presenting certain characteristics is expected to be away from work at some point in time or not. In other words, we want to know for how many working hours an employee could be away from work based on information such as how far they live from their workplace, how many children and pets they have, do they have higher education, and so on. Good. We've set the ground for our exercise. To proceed with further analysis, we will need to look at the data we have at our disposal. That's what we'll do in the next video. We'll be waiting for you there. All right, so the dataset we'll be working on is based on the dataset of an already existing study about the prediction of absenteeism at work. This means that the business exercise you will go through will be realistic, and the skills you will have developed by the time you complete it will have 100% application in the business world. It can't get any better than that, can it? Let's begin. When performing research, you will always have to work with some data. It can be classified into two types: primary and secondary. A non-professional way to define primary data is to call it data you have created. For instance, if you are conducting a survey or a questionnaire, the respondents answer questions, right? The fact you are conducting this survey means you are creating the data. Other people are answering, but you are the one asking the questions and collecting the answers. In a business context, companies create data all the time. Strong numeric information about sales operations, changing inventory, and filling out the accounting ledger are all instances of primary data. It is information that did not exist in any form prior to this moment. So, when you are thinking about business intelligence, often the data is primary in-house data. The other, and actually more common type, is called secondary data. This is an already existing data set that somebody else has gathered and organized, not yourself. Data that you have downloaded from an online website for free or data that you've bought from an organization are both instances of secondary data. It is important to realize that primary and secondary sources of data are relative terms. All of the data sets that you've seen and used in this course are secondary data for you. However, from our point of view, some are primary because we've created them, and others are secondary because we've acquired them from a third party. Okay, great. Now, regardless of whether you are dealing with primary or secondary data, you will have to do data pre-processing. Data pre-processing is an essential part of every quantitative analysis. It is a group of operations that will convert your raw data, that is, the data you have been given, into a format that is easier to understand, and hence, useful for further processing and analysis. This step attempts to fix the problems that can inevitably occur with data gathering. Furthermore, it helps organize your information in a suitable and practical way before you do your analysis and start making predictions. Having said all that, remember, we will be working with secondary data. We will call the initial set raw data. It will not be polished or prepared for analysis, but that's something we'll do in the next section. Thank you for watching. That is easier. Pre-processing is an essential part. All of the data sets
Ya, halo Bang, siapa nih? Pada indahnya bertemu dan melupakan seperti banyak yang sedih popang. Gak bisa ya apa-apa. Signing to check. Kalau penasaran aja aku. Oh, belajar resiko besar. Oh, belajar resiko besar. Oke, kita lihat belajar. Belajar aja. Satu jam. Oke, sebenarnya goal aku hari ini udah selesai sih. Tapi gerbangnya belum buka nggak sih? Belum telepon. Belum buka. Samar ya? Aku samar ya lagi. Sekarang ya? Sekarang ya? Nah, di sini tuh dia udah masuk ke bagian sebenarnya study case ada satu. Absenteeism. Absenteeism. Pre-processingnya 1 jam setengah. Diapain? Import, checking the content, multiple meanings, regression analysis, dropping a column, reasons for absence, dummies, dummies again, dummy, classifying, concat, concat, reordering, checkpoints, checkpoints, the dates, the dates, what the fuck is this? Remarks, export. Jadi pada intinya kita di sini membersihkan data ya, processing data. Oke. Terus setelah itu apa? Apply machine learning to create the to create the absenteeism model. Jadi di sini kita apply machine learning untuk membuat model. Nah, ini kita bakal exploring the problem, buat target, selecting input, standardisasi, splitting, fitting, summary, interpreting, standardizing, interpreting again, backward, testing, saving, pickling, saving, deployment. Jadi deployment itu ke dalam sebuah modul. Wow, sebelumnya nggak kayak gitu kan? Nggak tahu dah, ikutin aja. Terus nge-load, kan kita tadi udah ngebuat modul, terus nge-load, deploying, deploying and exporting, analyzing the predicted outputs in Tableau, H versus probability. Ini tuh masih yang tadi, tau nggak? Analyzing the predicted outputs in Tableau. Di sini kita akan menganalisa output yang predicted predicted outputs in Tableau. H versus probability, reason. Oh ini sama, masih sama konteksnya. Dah sampai sini aja berarti. Sampai we use Tableau. Terus di sini ada additional Python tools, nested loops, list comprehensions, and functions. Terus di sini ada pandas, kayak pandasnya aku belajar sih, lumayan kayaknya. And the last one is bonus lecture. Berarti yang penting aku itu target selanjutnya adalah menyelesaikan berapa subbab ini? Menyelesaikan 4 subbab. Processing, loading, create the model, load the model, and use the Tableau. So ada 4 objektif yang harus aku selesaikan. Ada 4 objektif subbab yang harus aku selesaikan. Dan untuk pandas fundamental ini sebenarnya opsional sih. Aku boleh belajar atau enggak, tapi disarankan belajar. Meskipun aku udah pakai pandas sebelumnya, tapi kalau misalnya terstruktur gini kan aku bakalan bisa dapat lebih banyak insight. Tapi nggak apa-apa. Sekarang apakah kita waktunya sahur? Jam berapa? Jam 9 aja. Lumayan sih. Setelah aku menyelesaikan study case ini dan lanjut ke sini, dapat sertifikat. Setelah itu aku bisa explore. Sekarang tanggal berapa sih? Tanggal 27. Tugas aku sebenarnya oke, sekalian lah ya, sekaligus kita atur apa aja yang harus diamin. Hari ini tuh besok ambil Google Cloud Platform dari IDGOJ. Ini kok tanggal ini sih? Tanggal 27 dong. Ambil advanced statistical methodnya udah. Quiz statistik, oh iya aku harus kerjain quiz statistik cok. Riset ini sampai tanggal 8 dan LIDM sampai tanggal berapa? LIDM itu sampai tanggal 12 April. 13 Maret. 12 April. Kalau Belatik masih belum ada info. GDGOC belum ada info. Tunggu si ini sih. Tunggu si. Saya pelan-pelan. Pertama ada GDGOC nunggu pala. Yang kedua ada LIDM tanggal 13. Belatik belum ada informasi jelas. Aku ikut apa aja sih? Banyak banget. Sakit kepala aku, Cok. Oke, pertama kerjaan aku tuh aset. Aset belum ada informasi aman. Di Pionir ada tugas ya, ada tugas. Itu tuh tugasnya sampai tanggal 8 harus reset fiber push notif aman di sini ya. Terus SRD ini gelatik belum ada informasi jelas. Hacker nunggu pala, psikolog aman, KMTD belum dipanggil, kerjaannya belum datang, tapi pasti bakalan datang. Game arti libur, LIDM-nya belum kumasukin. Oh ya kan pada LIDM. Berarti LIDM, berarti pas. Ada lagi nggak? Aku takut kelupaan sesuatu. Dan di sini aku bakal nambahin Udemy absen gimana sih? Absenteeism. Absenteeism. Nah ini tuh objektif sampai tanggal. Selesai 2 hari cukup sih. Harusnya sekarang hari Kamis 29. Selesai nggak sih tanggal 29? Masa tanggal 29 belum selesai sih? Lemah kali. Oke, tanggal 9 ya. Tanggal 9 doang ya. Selesainya Jin. Eh, aku juga ada tugas kampus aja baru ingat. Tapi aku belum tahu itu tugasnya apa dan kapan kumpulnya. Besok aku tanya. Terus ada pendaftaran. Pendaftaran lomba data science. Sampai tanggal 13 April. Jangan sampai lupa. Hmm, oke, aman lah ya. Oke, berarti ini masih tenang sih kerjaan aku. Nggak bentrok-bentrokan. Sekarang kita kayaknya kita sahur guys. Sahur habis itu tidur. Oke, cukup lah. Berarti besok kita objektifnya bakal memulai pro, apa project update absenteeism. Besok pagi aku ada kelas. Harusnya kalau ada kelas. Siangnya nggak tahu ada kelas atau enggak, tapi ada kelas. Tapi aku bakal ke perpus jam berapa ya? Sebisanya jam berapa? Oke, udah sekian dulu. Besok kita lanjut ya. Kita sahur. Goodbye. Terus lanjut aja. Beli aja makan sahur terus lanjut belajar. Kalau kita mau buat besok aja kita lanjut.